chapter should be equal to.
I'm going to catch up to you guys a little bit. That's all I want for part of that. Part B. Oh, this is the part you had a bit of a choice to make. I'm going to make a choice, and you could have made a different choice, but I'm not going to do it both ways. It doesn't really matter. Nothing really matters. I think I said 3 sides, $10, right? So you could pick any 3 sides. So if you pick differently than I did, my L could be your W, and your W would be my L. You see what I'm saying? The L and W are just dummy variables. We have to end up with the same dimensions, but what your L's value is could be my W's value. You guys cool with that? And it's something you should have picked up on the way. Variables are dummy variables. Who gives a shit if it's Y or X or L or W? So if I just pick, what did I pick? I don't remember, so I'll just do it. I'll do it live. So 10, L. So those 3 sides, and the last one is 15. What does each of these represent now? Cost, the total cost. So the cost to fence this side would be 10W. This is $10 per foot, W feet. So that's why I made cost red on the test, and I know I made it not, you didn't have to finish it. I understand that. But I wanted to really, if I said find the minimum blank, your whole first goal is I got to create a function for blank, because then I can do shit to it. And how do I find the minimum cost? I would eventually have to do what to a cost function? If I want to find the minimum cost, if I have a cost function, I can take derivative, the critical number, blah, 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 blah. Right? So, of course, the first thing we're trying to do is to set up, in this case, a cost function. Because then I can do stuff to it. Nowhere do I say anything about perimeter in this problem. Nowhere. Shouldn't show up. So what is the total cost right now?
25L.
Yeah, 25L. What's 20W? Now, depending on how you rearrange this, it could be 25W and 20L, right? Some of you guys maybe did that. But again, L and W, who gives a shit? These represent numbers, and it doesn't matter if I flip them. Who cares? So part C says, take the area, solve the area function for L. What do you get? You get A over W. So remember, this is like the tell me, ask me thing that we've done before. Tell me, ask me. You tell me the area, I can use that in what they ask me. Because what sucks about this right now, for taking derivatives, how many variables are in there? The number of variables is too damn high. So I want to replace one of them. It's very subversive. I just thought substitution method was very sneaky. That's why I like the elimination method, very direct, die. But this is very subversive. We got to use it. If I write this as now 25A over W plus 20W. Now I have a single variable. The cost is a function of. And that goes along with the title of this class. Single variable calculus. Calc 3 is multivariable. And then the next step? I don't even remember what I had you guys do. Take the derivative of the cost function, 11. So if I rewrite the cost function like this, just to make it look a little better, what's C prime going to be? Good. Let me just throw that back down there. Plus 20. 11. Right? Then how do you start finding critical number? One critical number doesn't make any sense. What's the one that makes the derivative undefined? 0 width, which wouldn't do me any good to like put stuff in. So there's a 0 area then I'm like, go us. So that critical number is related to the bad extreme. That would be the minimum area of 0. It would probably be a big cost. So W not equal to 0. How do I find the other kind of critical number, where this, of course, is where the derivative equals 0? Okay. This problem we're doing right now, it captures the general flow of most of these optimization problems. They ask you to minimize or maximize blank. You take a while to figure out what blank's function is. You make sure it has only one variable, take its derivative in critical numbers. I mean, it's a very, very recipe-ish thing. This step here is not recipe-ish. Is it a rectangle? Is it a triangle? Is it a distance between 2 points? Is it a cost? Is it a volume of some weird thing with a dome on it? Shit. But it's all trying to get the function so you can work with it. This is a huge thing that should have been done in pre-calculus. I have no idea if it was done well enough with you guys. I have no idea how long it's been since you took pre-calculus. So it could be a couple things going against you. Okay. So if I set this equal to 0, solve for w, I can add this stuff over, multiply w squared up, divide 20 down. I get w squared equals 5a over 4. Is that cool? I could even try to write it so humans could read this. Cool? And then what's the width then? Square root of?
All that.
All that.
Square root plus or minus 5a?
Now, why is it not plus or minus? Math would say plus or minus. We know that w represents width.
All right.
And I don't want to go into some other dimension or something to create this thing. Here's my garden. You got to go into the 7th dimension. Now, real quick. I know one level of the one we're doing right now you guys don't like, and that's the fact that I don't know what A is. But I kind of wanted to show you how I could develop a problem. What would I do next to give you guys a problem? I would figure out what A is so that you can do the square root of this number. And then that's what I tell you the area is. So if you look at your tests, there were several different versions, and there were several different numbers for the area I gave you. And each of those numbers makes this a doable thing. Right? Can you guys take a minute and try to figure out a good value of A that would make this a nice width? Don't say anything out loud. Oh, yes? No, because you added. Yeah, part of it was negative to begin with. Thank God, because otherwise, square rooting a negative thing, and then it's really, that's like the 28th dimension. There's only 10 dimensions, or maybe 11. Somebody have a good value for A? 20? What does 20 do for you? Yeah, and then you get 25 and the square rootable. So if I had the problem and said the area is supposed to be 20 square feet, this would have worked out beautifully, right? Anybody else get a different number? Or you guys like, we got the same one. All right, anyway, so that works. So if A was, if I told you the area was 20 square feet, oh my gosh. You got to get retired there. A little green marker. Then that means the width would be the square root of 25, so it would be 5. Is that cool? The width would be 5 feet. So what would the length be? Right? It's 20 divided by the width, so it would be 4 feet. Now here's what's really cool about this problem, and I hope, no matter what, you can kind of see this. Do you guys remember if I have a rectangle and I'm like, what makes the largest area? It's always going to be a square, right? If I don't have like a river on one side of it or somebody's house or something. You guys remember that at all? It's a square as the most efficient use of material if it has to be quadrilateral. The circle is the best, but I won't. What's the cost of each of these sides. What's the cost of this side now?
It'd be 4 times 10, so that'd be 40.
40. So this would be 4 times 15, which is
15, 60.
60. This would be 10 times 5. 50. 50. That is a square, I argue. You see how the length is 100 total? And this is 100 total? For this kind of problem, that would always, always happen. So in a way, there is a sort of square in the answer. I know this isn't a square when you look at the numbers, but look, there's 100 total length, 100 total width. That is neat. Or at least I thought so. Did you have to do any of this shit? No. What's the total cost? $200. Right? That would be the end of that problem. You just figure out the total cost. So that's exactly how you do number 6 on the test, and also how you do several problems in the homework. Now, I know you haven't had a chance to do this yet, so look at number 2. Go ahead and try that one out. Just to remind you guys. What's the distance formula between 2 points?
F of B minus F of A over B minus C.
Who to what? Do it again. Distance formula.
F. Oh, wait. What?
So it's an extension of the Pythagorean theorem.
Yes, it's based on Pythagorean theorem. Because if you have a point and another point, here's one's x's, here's the y's, here's the distance, right triangle. Pythagorean theorem.
Oh, okay. This one. Oh,
So what I'm asking you to do, can you imagine if I said minimize the distance, wouldn't this be a remarkably disgusting derivative? But if I minimize or maximize the squared distance, that would still give you if I minimize the square of something, I obviously minimize the something. Because that something, in this case especially, is positive. So try to do number 2.
So I'm going to guess X2 and okay, so let's think this through. So if you put in the next one, you get y, you get x, no, x2 minus x1. So that's, let's see, if you plug in,
Yep. I don't know why I put the square on the inside there.
so if you plug in the x, you get the x2, right? If you plug in the x into the function, you get x2.
You have to fill out all of the
Then what?
Are you trying to substitute the one or something?
I'm trying to substitute. What I'm trying to do is I'm trying to get x2 y2.
Make sure everybody's got the... How did I set this equation up? What did I have to give myself first?
You have to give yourself
2 points.
2 points.
You guys can all see a point.
Yeah, we got
You got 1 point.
1 point. So
You also have an infinite number of other points.
yeah.
So just pick one of them. Maybe call it something that's general.
All right.
I'm going to let you guys think about that before I say any more.
Oh, wait, but you can solve for x and y. Are you saying with x and x?
We could solve
Yeah,
for y.
to y equals x squared minus 1 because... Oh, there is some solve for y.
It is solve yourself.
So
it's a general point on that
x
function.
is x or x.
Well, you can put x squared minus 1 and substitute the x for x1 and x2. Because that would be the value of x1 and x2. What's this? Yeah. It sounds weird because it's...
All right, let me see what's happening. What's the 1 point with just numbers that I give you? 2? Negative 1/2? Ooh, yummy. The other point comes from where? Comes from this, right? So give me every point on that function. I'm just going to put it somewhere. There's an arbitrary point. What is that point's coordinates? I'll start us off. Okay. That's not good enough, though. It has to be on this parabola, and I know the definition of the function, so how can I rewrite this so it's more specific? X, comma? Yeah, holy shit, because that's what y is. So another way to say the function x cubed minus x is this. There's the function x. There's all the points that are on the function x cubed minus x. There they are. Isn't that the same thing as saying y equals x cubed minus x? Okay, they're the same thing. So this is y equals x squared minus 1. Now I have this point and this point. Keep going.
Okay, so here's the points. So now we put in the function.
Put in the points. The points and the function.
We should probably do what? Now that we have that point.
Okay, so you're counting for 1 x 4 is 2. And this will still have 7. This one's 7. And this is going to be x squared minus 1.
This is? Oh, yeah.
So let's see. So square root.
Oh, no, we're not doing anything.
Actually, it will be minus x squared minus 1.
X minus.
So see, those are your two parts. So I would call x squared minus 1, I call x x cubed.
Oh,
So then just plug them in. What's x1, y1? 2. Any choice. Those are my 2 points.
So that's our.
Then they ask you to minimize it. They can compare it to So it's all about what are they asking you to optimize or minimize whatever.
Well,
Make a function for that.
Square root.
Really square root. Setting a function. Yeah, I would do it as x2, y2. Just so they'd be first. But the ones that
no, we can just.
does it really matter? Just worry about
You take the derivative.
Different
Oh,
policies.
you can't. Yeah. I see what you mean. That's what reserves.
So let's see, let me catch up to you guys. So I do. There's x2 minus x1, y2 minus y1. It doesn't really matter which way you go, but you see how that has 2 terms? That's why I decided to make it show up first, so I didn't make any stupid negative distribution mistakes or something. You normally put your variable piece first too, yeah.
I thought 2 was the x one.
Totally.
For the x minus 2.
Yeah, so x2 is this, x1 is this.
Oh, that's the x.
Yeah, yeah. Yeah. Okay. And now it's just a bunch of, well, first thing, let's see. This would be x squared minus 1/2 squared, right? So then I get x squared minus 2x minus 4x plus 4 plus x to the 4th minus 1/2 x squared minus 1/2 squared. X squared is minus x squared. Negative half times negative half is positive 1/4. Just a bunch of foiling, which shouldn't trouble you. So I get x to the 4th, let's see, minus 4x plus What would that be? 17 fourths? Ain't that yummy? Now, so, that was cool. You're feeling, I'm glad you said that. Just playing off of last night's. That is the distance function. I know it's still squared, but we realize that just makes the derivative. If I said find the minimum distance, now watch. Where's 2 negative 1/2 would be like, right, let's say here, right? So I want to find a point on here that minimizes the distance. It looks like it's going to be in here somewhere. Do you guys see that? If the question was minimize the distance, why does that question make sense? Because that's pretty far away, and then it's getting closer, and then it's getting further and further away. So somewhere in here is going to be a point on that parabola that is the closest to this. What does that sound like in real life that we would be curious about? What does this kind of look like? Here's the Earth, and here's a comet or meteorite or possible alien spacecraft that went through our solar system a while back. It was just a weirdly shaped asteroid that everybody went, oh my God, it's the aliens. No, the aliens don't know we're here. It's too many places to look. So that's one reason why I'd want to be able to do this kind of math, is to see the closest approach of something. And there's going to be a little bit of error in that. And we're like, if we are in the error bound, we better mobilize, Bruce Willis and everybody. Get up there. No, is that too old of a movie, really? Okay. Like, what would John Clay do then? That's still too old of a movie. All right. So let's do this. Let's try to find the minimum squared distance. So I would just take this function. Gosh, all my markers are dying. How would I find the minimum? What would I do? Take a derivative. I think my red one's not too bad. Don't worry about, this is my function. Don't do any 2D bullshit. I'm minimizing the d squared function. So d squared prime equals. Good. Keep going. Find the critical numbers. I only care about real critical numbers. This is not complex analysis class. That's a fun class.
What is equal plus or minus?
This is your favorite factoring form. Or you just freaking cube root.
True.
So what do you do to find the critical numbers? Equal it to 0. Add 4 over, divide by 4, take the cube root. Now how many answers did I lose by not factoring? I lost 2 answers. Those 2 answers are both complex. So who gives a shit? Bye. When I have a cube, I should have 3 answers. 2 of them are not real. And we're dealing with comets hitting the Earth and all that shit. Again, we're not worried about the 28th dimension, whatever. So let's see if that makes sense. So what point? 1, 0. That's the point. That's the closest. So 1, 0. Where'd it go? 1, 0. Well, that makes sense because it's on the thing. That's the point on the parabola that would be closest to this point to negative 1/2. Eyeballing it, you could have seen that it kind of should be that, but you don't really know until you do the math. Because it could have been, 0.9, 0.02 or something. How? Yes? No? Maybe? There are some problems in that 4-7 that are just like that. Okay. So what I want to do is I want to talk about 4-9, talk a little bit about 5-1, and then go out into the world. Right? Spread the message about calculus. You gotta love the title of 4-9. And I kind of gave you some bonus problems. We did talk a little bit about this, but it's just antiderivative. It's sort of like when you learn distribute, and then before we call it factoring, I call it undistribute. And then I say, oh, guess what? That's a form of factoring. Ooh, so they don't get all freaked out right away. Save the freak out for later. So if I told you the derivative of some function was 4x cubed minus x to the 5th. It's a nice mixture of easy and still easy, really. But what must the function have been? Yeah, so you just got to think backwards. X cubed would have come from x to the 4th, right? So really that 4 just kind of migrates back up. But what's up with this guy? Where would he have come from? Yeah, be careful. Let me piece this together. Something to the 5th would have come from something to the 6th, because to take a derivative, I've got to take it down. So to take an antiderivative, the power goes up. If I take this guy's derivative, do I get this? What do I get that I don't want? Stupid 6. Kill it. This is a beautiful thing that comes into play in a lot of antiderivatives that we'll do. Yes, I will call it antiderivatives until we prove that it's the same as something called the integral. We actually have to prove they're the same. I'm not done with this, by the way. But this idea of, I know it comes from something like this, but it can't be that because I get an extra 6, so let me just kill the extra frickin' 6. Now, why is this not done yet? What is here? And whose derivative would be 0? A constant. I love it. If you've taken any calculus before, you remember that plus c that you lose points if you forgot to put plus c. And you're like, sometimes I don't need the plus c if it's definite, no. If it's indefinite, yes. And that's all shit in our future. But do you see why that's there? What does the derivative tell me about a function? The slope. So it really tells me the shape. Remember when we did that sign diagram for the first derivative and I got my critical points? If it was plus minus plus, I could draw a shape of this. Right? Going up, flat, going down, flat, going up. I know the shape. But I don't know where the shit it is. Right? It could be up here, it could be down there. This is the y-intercept. It's the pin you put in it. So you got the shape. I'm like, where do you want me to put the shape? Right here. Pin. So whatever value this is, it actually puts it in a place. This only tells you the shape. Why is there an unknown here? Because it doesn't tell me where the shit it goes. So if I told you I have a line with a slope of 2, can you draw it? What would you, if I said draw a line with a slope of 2, there's only one right answer, you're like, I need more information, right? What else do you need to know? Yes, that would be very good. So that's the y-intercept. Right? So most of the time it's the y-intercept, but it's just a point. I need to have some point to get me started. If I told you it goes through 1, 3, then it can go up 2 over 1, boom, boom, there. Oh, gotcha. Okay. Right, so the slope by itself is not enough. I've got to give you some idea about where it is. And that's why this plus c shows up. All right, let's try a few more anti-derivatives. If you suck at derivatives, you're going to extra suck at anti-derivatives. Right? If you can't drive in drive, you're really going to have trouble in reverse. I mean, that's really what's happening. All right, let's start off nice. 11 people are like, that's nice. But if you know your derivative rules, most of these should be very easy. So if f prime is that, what must f be?
Secant x plus c.
What? Sorry, say it again.
Secant x plus c.
Good. Secant x plus c. And how do you check yourself? Check yourself. Check the derivative. Yeah, that shit. So when you factored polynomials in algebra, how did you check it? You multiply the shit back out. Right? Now, if you just stop here, the check will work. That, of course, you just have to remember it's got to be there, because it could be there. Okay. All right, what about this? Let me step it up a bit. Now this isn't really a big step up, but oh well. Let me give you a little bit more of a step up. You ready? You're not ready. We'll find out if you're ready. Ooh, I like it.
Alrighty, let's
We'll do this problem and then we'll set up our first antiderivative rule.
In order for that to be there had to be a 1/2.
So guys, help me out. What would this be?
No,
Where'd this guy come from?
X minus 7.
ln x minus 7. Now, where would this have to have come from? X to what power?
the 1/2.
Is that good? I'm not done, obviously. I've left a lot of shit blank, but I know that for damn sure. But if I take this guy's derivative, what do I get that I don't want? A half. So what should be there to kill it?
2.
2, which is 1 over 1/2, isn't it?
Yeah.
We did that problem here. What do we do? That's a 6. I put a 1 over 6. That's a 1/2. I need a 1 over 1/2. There seems to be like a rule there. And of course, what's missing? Plus c. Like that. So here's the rule. Let me remind you of the most basic derivative rule, what it looks like. Remember the days back when you thought this was hard? And now you're like, my God, give me more of that shit, Jeff. What's the derivative of this? So now, if I have the derivative, it looks like this. How do I get the antiderivative?
N. No,
Careful
N
now.
minus
What does the power become?
N plus 1.
So if you took this guy derivative, that would be there. You don't want it, so it's going to be over.
Over N plus 1.
I like it. So look how this makes sense. The derivative is the old power times this to the power minus 1. The antiderivative is the power add 1 to the power, divided by the new power. It's kind of like the opposite, which just makes sense. It's the antiderivative. So what do I do first when I'm faced with a problem like g prime of x equals x to the negative 7 ninths? I need to figure out what g of x is. What's the first thing I write down for myself?
Let's see.
I write down x to what would the power have been? Where would this come from? X to the what would lead to this? Here's the shortcut. Do you remember when you took derivatives? You did that minus that? I don't know if you guys remember that shortcut I showed you a long time ago. That's really, really fucking useful. So to undo it, you do negative 7 plus 9 is 2. So it came from 2 ninths.
And then it'd be 9, or it would be multiplied by 9 and it'd be divided by 2.
Beautiful. So times the reciprocal, right? Because the general rule is you divide by the new power. So if it's a fractional power, that means multiply by the reciprocal. How do you check yourself? Well, the 2 ninths would come down, Cancel with this shit. Subtract 1. Beautiful.
And also don't forget the plus C.
There you go. So I would hope it makes sense that the easiest derivative rule should lead to the easiest antiderivative rule. So let me use some notation that you see all the time with these, because I want you to realize I give you a function, you can take its derivative. I should be able to give you a function and you take its antiderivative. It doesn't have to be like, somebody took a derivative, can you undo it? No, it's just a function. It can have a derivative and it can have an antiderivative. Those are two things you can do to it. So if I give you, so the notation normally is, let's say I give you this. Yeah. So if I give you a function f, its antiderivative, we call it what I affectionately call big ass f. So this is the antiderivative of f. So if I had g, the antiderivative would be big ass g. Right? Sounds safe. All right. What would that be? Now, this gets interesting. Got to think backwards, and cosine and sine are always. No. What do you take the derivative of to get the cosine?
Sine.
Sine. No negative needed.
Yeah, sine.
Yeah, sine of this, and I like what you noticed. This can't be true because its derivative would have a 3 come out, so what should be out there to kill it?
A 3, or 1/3.
1/3. To kill that 3 that wants to come out.
1/3 plus 2x
Good. Plus 2x.
plus c.
Plus c. Kick ass. The better you know derivatives, the easier this should be. This idea of chain rule is the thing that kind of gets us. And the chain rule would have let a 3 come out there, so I have to have its inverse to kill it there. There is something we'll learn later that's called substitution method. But I'm trying to get you to realize we don't need that shit for this basic stuff. I only need it for the freakier stuff. Okay. Let me think. Was there something? Oh. Let me give you one. All right, let's see what you guys think about this.
Alright, so in order for that to be there, so it'd be...
So let me just say this and give it away. You cannot always find an antiderivative of something.
Oh, right. I don't think this can be.
This is called a transcendental function. I mean, that's like, hello. So there's no what's known as a closed form for this guy's antiderivative. When you take Calc 2, you'll learn more about what closed form means. If you never take Calc 2, don't lie awake at night. You know, what's closed form? So there is no antiderivative for this. That's the most classic function that has no antiderivative. Think about it. Wouldn't it come from this? Right? But what should be there? Because if you take this guy's derivative, what do you get out for? You get a 2x, right?
Yeah, 2x.
Do you see how it's missing a functional piece? Now, look, wasn't this missing the 3 that would have come out from here, right?
Yeah.
But a constant doesn't change me. I don't give a shit about constants. I just worry about that. Oh, no 3? 1/3. Okay. But if I'm missing a functional piece, I am screwed. I can't just do this. All right, so the answer is going to be over 2x. I can't do that because now how do I take this guy's derivative? Is it going to be this? No, this is freaky. This is a bring this up, product rule, bullshit. Oh my God. Constants, you can always balance. You take any chemistry, you get the idea. Even if you don't. I'm not supposed to have a 3, so I better put a 1/3 there. That would have killed the 3. You can balance constants. Functional pieces, you're screwed if they're not there. really lay that groundwork now. So you cannot always find an antiderivative. Doesn't mean that one doesn't exist. It just looks strange. It's an infinite series. That's all I'm going to say about it. Just realize it's just strange. Take Calc 2, you're going to do it. Okay. So that's section 4.9. One extra piece in 4.9 before I forget. Let me give you a semi-simple example. Doesn't matter, Jeff. Just make something up. There you go. Look, you're right. All right. So I'm going to give you a little extra piece. So find f of x. Okay, that's what we've been doing forever. Do that. Then worry about so that this. Then worry about that next.
Okay. Oh, let me think about that. Okay.
So do that on your own.
Not for that to be there. That would be to be.
So do you create your f of x when it says derivative?
That's right. So, but
F
prime is related to f the same way that f is related to big S.
equals
Big S f is x
x cubed plus
So the way you write that.
x squared
over
over 2.
The big letters normally
All right, I think I got it. Now let me see. That's right. Plus C. Plus C. Yeah.
Later.
Now, come to the point.
But for right now, the big
Oh,
S
wait a
letters
minute.
stand for.
Why did it be 5 plus C? I'll just.
No, because C is defined.
So if you took another antiderivative, you just make it even bigger. The eighth integer is China.
Plus.
So let me catch up to you guys. What'd you get for just big ass f? Just doing like we've been doing.
X cubed plus x squared over 2.
Good.
Plus C.
So what is this going to do for me that we haven't been able to do anything about yet until now? Help me figure out what C is. I love it. So we know that f of 2 equals 8 plus 2 plus C is supposed to be 5, so C has to be negative 5. So f of x is x cubed plus 1/2 x squared minus 5. Bam! So that's that anchor point. This is floating in the air. This is a slope of some other function. It's just so it's floating. And then this is the anchor point. This is where I put the pin. So that's why this is now totally defined. So, now, that's 4.9. 4.9, the better you understand derivatives themselves, the easier 4.9 should be. And at this point, you really should know derivatives. Per. So do you remember, I showed you guys I think I did take a side step, but didn't I show you how the area of a circle was created? Or was one way to kind of come up with it?
A 1/2
You
pi
chop it up into another, yeah.
Yeah, I remember.
Makes a rectangle. That's all you had to say, so I'm like, yes, I did tell you. Because otherwise you wouldn't just look at a circle and go, makes a rectangle. So I must have told you. It's where you cut it up, bam, 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 and you put them all out there and make a rectangle. All right. So, what we're about to do is if I have a function and I want to find the area, is there, right? Under that function, that's what this next thing does. So, 4.9 is antiderivatives. What we're about to talk about is what's known as the integral, which is fundamentally finding the area under a curve. And a better way to say it is between the x-axis and the curve itself. So do you see how areas could actually be negative? Some people that teach this have trouble. They say there's no negative areas. There are negative areas. There's are. So if this was my profit function, what happened here? I lost money. So the area would represent the amount of money that I lost. Therefore, it's negative area. Nothing wrong with... I can have negative velocity. It just means I'm going the other direction. I can have negative area. It just means it's going the opposite. It's going to take away from my total area. So get over negative area if you have a problem with it. Teachers. So this thing we're getting into right now is called integration. We will talk about integration itself, which is finding the area. That's all it is. So if only this was if this was this kind of a function that was flat, the area would just be the area of a rectangle. I don't need no freaking calculus for that shit. Somebody ever taken statistics? Uniform probabilities, do you remember that? Where you just find the area of the rectangle? And then you go to normal distributions and you need help. Because you don't know what the area is under that shit. Alright, sorry. That's it. That's it for the stats side note. You're like, I didn't take stats, shut up. So, how do I find the area when I've got these shapes that I obviously have no idea what the geometric formula would be? If I have a curvy side, that's not a trapezoid. Yeah, so what I do, so for example, if I said estimate the area of this, how many of these fit in there? One way to do it is just draw a bunch of those and get an estimate. Will it be exact?
No.
No. Will it be a decent estimate? Yes. So here's what I do. This is unbelievably awesome. You must allow it to be. Some of the symbols we're going to use to capture the idea are freaky. But the idea, never forget, it's just adding rectangle areas. That's it. So what if I did... So if I draw a rectangle, there are two sides to the top, right? There's two vertices, right? If I draw... There's this one and this one, right? And they kind of tell me how tall this thing is. So I can draw this in such a way that I can make rectangles where the height is how... So how tall are these rectangles that I'm drawing? They're based on... Do you see how the height is based on the left function value? So how tall is this rectangle? How tall is this? F of A. I love it. For example, right? Kick-ass. How many rectangles did I draw in there? 5. How wide is each rectangle? Yeah, you have a total length of B minus A, right? And I chop that length up into 5 intervals. So each rectangle would be B minus A over 5 wide. All right, let me stop for a second. Let me make sure you guys absorb that fully. Because this is the remarkably easy part. You haven't done anything too crazy. If I had a 10-foot wide place and I put 5 rectangles in there, how wide is each rectangle? 2 freaking feet to fit in there, right? So here's how wide of an area I'm working with. Divided by 1, 2, 3, 4, 5 sections. So each section is that wide. So can anybody tell me the area of that first rectangle? It's this tall and this wide. F of A times B minus A over 5. All right. Now that looks disgusting because I don't have any numbers yet. I don't have a function. I don't know what A and B are. But does that feel like it's going to be difficult? So let's do a concrete function between 2 given values. Just to show you, and then so I want to do a complete problem, and then I want to show you the symbols that captures what we did. Just to make sure you understand, the symbols are important, but I don't need them to do a specific problem because it's just areas of rectangles. How do I increase the resolution, by the way? Would you say that this estimate I'm going to get is going to be good? Not great, not like horrific, right? If I use one big ass rectangle, that would be horrific. How do you dial up the resolution? More rectangles. What this problem needs is more rectangles. Oh, sorry. Cowbell? No? Okay. Thank you. So eventually, just because this is too easy right now, I got to throw some shit in here for you. Eventually, we're going to let the rectangle's number go to infinity. If I let the number of rectangles I use become infinite, then my answer is perfect. It's not an estimate. And you're like, and we shouldn't be too freaked out about that. We really shouldn't. What does that entail? Setting up something that's based on n and letting n go to infinity. We did all that limit work. If you were hoping limits were in your past, you're crazy. So let's do a problem together. And then I got a little handout. Or actually, you guys already got it. It's on the back of that thing. Don't look at that yet. So let's do one that's nice to do real quick. Darn it, I have one good marker. It sucks. Oh, I got a glue one that might work. Let me say using 3 rectangles to make this nice and easy. Nice and easy. Sorry, Sean. I have no idea. Take a second and give a rough sketch over that region. It's the kind of thing you should be really good at, which is